So this is our introduction to solving two-step equations and inequalities. You should have seen a little bit of this last year and some of it on our homework with the one-step and two-step equations. Now we're going to really figure out the differences between equations and inequalities and get into a little bit tougher equations. I want you to try the warm-up on your own. It's saying that we want to use that picture to find the value of a circle, one circle, in terms of a square. So basically, how much of a square is made up with one circle? So try your best on that. We'll come back to that at the end because we have a problem at the very end that's very similar to that. Right now I'm just going to go through these notes on equations and inequalities. So an equation is basically looking for a value of an unknown number. And it's going to make both sides of the equation equal to each other. Both sides are going to be equal. And the way we do that, the way we get a variable by itself, the unknown variable, we have to use inverse operations. We really want to work order of operations backwards. That's all we're doing here. We're working order of operations in the exact opposite order. And we're going to do that with inverse operations or opposite operations to undo the original operation. So here we have x minus 5. To undo that, we'll add 5 to both sides. Adding 5 to a minus 5 cancels out, those are opposites. And we're just left with x there. We're going to add 5 onto the other side. If you do something on one side, you have to do it to the other. So add 5 to the other side, that would give us 15. So x equals 15. I know most of you probably don't have to write out that step, but I really want you writing this in the beginning because these are going to get much harder, and if you take it step by step, it's much easier. If you try to guess and check, this will not work. Especially if the answer is a decimal or a negative, it's much tougher to just guess and check. So please write every step out. The reason I'm writing the line in between is because I know that I have to do something on one side, and I need to do that same thing on the other. I want to make sure I'm doing it on the left and on the right. I'm going to do the exact same thing with the next one. I'm going to use inverse operations again. So the inverse operation, or the opposite operation of square rooting something, is squaring something. Those are opposites of each other. That's what I have here. I have the square root. The square root of x can be canceled out by squaring that, and I would square the other side also. So x is left by itself on that side, and 4 squared is 16. You can always check your answer just by plugging it back in. The square root of 16 does give you 4, so we must have done that right. The next one is where we really get into thinking about order of operations backwards. I want to picture a number in here. I want to imagine, let's say we put the number 100 in there. 100 minus 3 divided by 5. If I followed order of operations, I would do the minus 3 first. If I'm working backwards, that's the last thing I have to deal with. So I want to get rid of that dividing by 5 first. So my first step here is doing the opposite of dividing by 5 or multiplying by 5 on both sides. You're just trying to cancel out the dividing by 5. That's all that happens. Those are completely canceled out. We have x minus 3 equals 2 times 5 is 10. Our final step would be to do the opposite of minus 3, which is plus 3. And x would have to be 13 there. Again, we could take that number and plug it back in. Obviously 100 doesn't work. But if we plug 13 in there, 10 divided by 5, that's 2. You can always check these. There's no excuse for getting a multiple choice question wrong. You can always just take the answers and plug them in and see what works. The last one, we have multiplication. 4x is really 4 times x. To undo that operation, we're going to divide by 4 on both sides. We get x equals 5.5. It's fine that that's a decimal. Again, you can always check it by just plugging it back in. 4 times 5.5 would give you 22. I'm going to keep going into that idea of checking your answers. There's no reason really to get these wrong because you can always just go back and see if it actually makes sense. So here we're checking to see if Isaac's answers are right. Isaac got 3 for the first one. So we're going to substitute that number in and follow order of operations. 6 minus 4 times 3 equals 18. We want to see if that's a true equation. We want to follow order of operations and see if we get 18. We're going to multiply first. We get 6 minus 12 equals 18. That's actually going to be a negative 6, so that does not equal 18. That is not a correct answer. Same thing on the next one. Let's plug in 16. 3/4 times 16 plus 9. We want to see if that equals 21. 3/4 times 16 is 12. Plus 9 equals 21. That is correct. 21 equals 21. That's how we can always check to see if that's right. Same kind of thing on the next one. We're going to plug in 5. 4 times 5 minus 1, all divided by 5. We want to see if that equals 3. 4 times 5 is 20. Minus 1 is going to be 19. 19 divided by 5. It's not 3, it's 3.8. So that is not correct. So when you're solving a two-step equation, we really want to highlight the part that's directly attached to the variable. This is going to say put a circle around whatever's directly attached to the variable. I don't really want to put a circle around it. I just want to highlight it. I'm actually just going to put an arrow and say this is what's directly attached to it. In order of operations, that's what we would do first. So in a two-step equation, it's actually what we're going to undo last. We're going to work backwards to that first step. So we're going to use inverse operations just like we said on the first page. And we always want to check our answer. So here we have a 2x minus 1 equals negative 7. That 2 is directly attached to the x. That's what we want to deal with last. So we're going to start with the other number on this side. We don't want to touch that negative 7 yet. We don't have to do anything with that negative 7. We want to get rid of the 2 and the minus 1, the two things that are attached to the x on that side. So we're going to undo this minus 1 first by adding 1 to both sides. Minus 1 and plus 1 completely cancel out. That leaves us with 2x, and that equals whatever negative 7 plus 1 is on the right side. That's negative 6. So we took care of the first step. Now we have to deal with that 2 times x. We have to get rid of that multiplying by 2. By doing the opposite, that's dividing by 2. So x equals negative 3. And we can check that by just plugging back in. 2 times negative 3 minus 1. 2 times negative 3 is negative 6. Minus 1. That's going to build and make a bigger negative. That's a negative 7, which is exactly what we wanted. On the second one, we have a fraction in front. So that's the thing that's directly attached to our variable. I'm actually going to change that into a decimal instead. I'm going to change that to 0.5 times x minus 6 equals negative 10. So we're going to start with whatever's not directly attached to it. We're going to start with that minus 6. We have to do the opposite of minus 6 or add 6. So we have 0.5x equals negative 4. And now we can get rid of that 0.5. That's multiplication right now. So we're going to divide on both sides. Divide by 0.5, 0.5 on both sides. X ends up equaling a negative 8. Again, we can check that. 1/2 of negative 8 minus 6. 1/2 of 8 is 4, so 1/2 of negative 8 is negative 4. Minus 6 is negative 10, which means we did that right. Three and 4 is where it gets a little bit tricky. So we want to, again, highlight which part is directly attached to the x. It's this minus 2 that's attached to it. We want to undo or get the opposite of the other number. We want to get rid of that positive 5. This is one of the trickier ideas because you see that minus sign and you think, I have to do the opposite of that operation. But the minus sign is applying to that 2. It's a negative 2x or a minus 2x. So we have to get rid of a positive 5 there by subtracting 5 on both sides. We're canceling out a positive 5 by subtracting 5 on both sides. This minus sign is stuck to that 2. That whole thing is going to come down. Negative 2x equals whatever that subtraction is. That's negative 14. And now we have multiplication. We're going to divide by the exact same number. We're doing the opposite operation. So the opposite of multiplying by negative 2 is dividing by negative 2. And there, x has to equal a positive 7. Again, we can plug that right back in. 5 minus 2 times 7 is the same thing as 5 minus 14, and that is negative 9. I'm going to show this in another way just to make this even clearer, that the 5 is a positive and the 2 is being subtracted or negative. So I'm actually going to do this again in a completely different way. I'm going to rearrange this equation, and I'm going to keep the signs with the number. That is a negative 2x or a minus 2x. Those are the exact same thing. I know that's a weird idea, but you have to get used to that. A negative 2x and a minus 2x are really the same exact thing as long as it's just addition and subtraction. So I'm going to rearrange this equation. I'm going to bring the negative 2x out in front, keeping the sign with the number, and I'm going to move the positive 5 to the back as a plus 5. It's a positive number, so I write it as a plus number. If I rearrange like that, then it's much simpler. It looks a lot more like the equations that we just solved. We would subtract 5 just like we did before. And we have negative 2x equals negative 14. And again, we would divide by negative 2 to give us a positive 7. It's a really important idea that the negative sign or plus sign is attached to the number. Whatever sign is directly in front of the number is attached to the number. On number 4, I really want you to think about order of operations backwards. If we had a number in place of x, let's just say we had something like 100 minus 2 over 3. We would do the addition, we would do the subtraction on top first. So this is the number that's directly attached. It's the minus 2 that's directly attached to our variable. That's what we're going to deal with last. We're going to get rid of that dividing by 3 on the bottom first. By multiplying by 3, we're going to use the opposite of dividing, which is multiplying. Those cancel out. We get x minus 2 equals, that's 3 times 3, or 9. And again, look at the left side. Nothing really got multiplied there. Nothing changed about the x minus 2. We just canceled out the dividing by 3. Now we can cancel out the subtracting 2 by adding 2 to both sides, and that would give us x equals 11. And let's check that one more time. X minus 2, or 11 minus 2, is 9. Divided by 3 is 3. Now we come back to a problem that's similar to the warm-up. What is the value of one circle in the picture below? So actually, we're going to learn a math equation way to solve this. But for right now, I kind of just want to use logic. We will learn how to set this up as a variable, this up as a variable, and these are our single units. But let's not worry about that right now. Let's just think about logically, if this was a balance, things that weigh the same on each side can be canceled out. We could take a circle off of here and take a circle off of there, and that remains balanced. That's the whole idea of an equation. If you do something to one side, you have to do it to the other to keep this whole thing balanced. So we take off one circle from each. We can take off these 3 squares from both sides. And that tells us that 2 circles equals 4 squares. So the value of one circle is really 2 squares. One circle equals 2 squares. The warm-up actually asks this a little bit differently. I'm going to go back to that now. I'm going to do the exact same thing. I'm going to cancel out one of these boxes from either side. It's still balanced. So now I got 2 squares equals 4 circles. This wants us to say, what's the value of one circle in terms of squares? So one circle equals how many squares? Well, one circle actually doesn't equal a full square. You can squeeze 4 circles into 2 squares, so you can fit 2 circles into 1 square, or you could fit 1 circle. Those are circles, not zeros. You can fit one of these circles into a half a box, or 1/2 a square. So one circle equals a half a square.